Good morning, everyone. Okay, so today we'll be learning about the structure of synapse and the role of the neurotransmitters. Okay, so class, for today's lesson, you must be able to describe the structure of synapse and explain the role of the neurotransmitters and common neurotransmitters. Okay, um, that presence. Okay, in the synapse, they are acetylcholine and norepinephrine. Okay, so for today's class, we only be focusing on the acetylcholine. So make sure you get the spelling of this acetylcholine correctly, as well as the norepinephrine, although I won't be discussing because their effects is more or less the same. Okay, synapse is part of the axon ending, okay, which one neuron connects to another neuron or an effector. Or you can simply define synapse as a functional junction between two neurons or between a neuron and an effector. Okay, so that's not that difficult, okay, to define synapse. Now synapse has synaptic cleft, okay, and this synaptic cleft is a thin space, okay, of 20 nanometer between membranes of a presynaptic neuron and a postsynaptic neuron, okay, or a fluid space at a synapse. So meaning to say, synaptic cleft, you can just define it as a fluid space at a synapse. So this is the synaptic cleft, right? And this is the synaptic knob, okay? And this whole thing here, okay, is the synapse. Okay, so again, a synapse has synaptic cleft, and the end of this synapse here is known as the synaptic knob. And if you refer to this diagram here, a synaptic knob has many mitochondria, okay, and many synaptic vesicles that contains neurotransmitters such as acetylcholine and norepinephrine. Okay, other example of neurotransmitters are like dopamine. Okay, and then we have this dendrite, okay, of another neuron. Okay, and this part of the neuron, okay, sorry, this plasma membrane of this subsequent neuron is known as the postsynaptic membrane, and this synaptic knob here has this presynaptic membrane. Okay, and if you look carefully on the postsynaptic membrane, there are many protein receptor that allows the um, influx or outflow of ions. Okay, to be more specific, okay, this protein receptor, okay, um, is known as the ligand-gated ion channel, which allows, okay, influx or inflow of sodium ions from the synaptic cleft into the um, postsynaptic knob. Okay, and it allows the outflow of potassium ion, okay, from the postsynaptic knob into the synaptic cleft. Okay, the reason is to propagate action potential from one neuron to another neuron. Okay, now let's take a look on the transmission of impulse across synapse. Okay, okay, so first things first, impulse will arrive at the synaptic knob of the presynaptic neuron. Okay, so this is the presynaptic neuron, and this is its synaptic knob. And the arrival of the impulse here, okay, at this synaptic knob of the presynaptic neuron will depolarize the synaptic membrane or presynaptic membrane. Okay, this will depolarize the presynaptic membrane. Okay, next, the depolarization of this presynaptic membrane will open up, okay, or activates, okay, the calcium ion gated, calcium ions voltage gated channel. Okay, will trigger the activation of this calcium ion voltage gated channel to open, and this will trigger the influx of calcium ions, okay, from the synaptic cleft into the synaptic knob of the presynaptic neuron. Now, the accumulation of this calcium ion, okay, will cause this synaptic vesicle. You can see the synaptic vesicle here, okay, fuse with the presynaptic membrane. Okay, now after that, the synaptic vesicle exocytosis, and this will release the acetylcholine or neurotransmitters into the synaptic cleft. Okay, so let me rephrase. Depolarization, okay, on this presynaptic membrane, okay, will cause or trigger, okay, the influx of these calcium ions into the synaptic knob, okay, and the accumulation of calcium ions here in the synaptic knob, okay, will cause this synaptic vesicle to be exocytosized, okay, and this will release neurotransmitters into the synaptic cleft. Now, this acetylcholine, okay, will bind to the acetylcholine receptor at the postsynaptic membrane. Okay, and then this acetylcholine receptor, also known as ligand-gated ion channel. You can see how this acetylcholine bind with this ligand-gated ion channel. Oh, this is closer up this diagram. Okay, now the binding of this acetylcholine to this ligand-gated ion channel will trigger the opening of this ligand-gated ion channel and allow the inflow or influx of sodium ions into the postsynaptic membrane, okay, as well as allowing the outflow of potassium ions out from the postsynaptic membrane. Okay, now the impulse will be generated at the postsynaptic membrane, okay, and the ligand-gated ion channels will close. Propagation of impulse continues in the postsynaptic neuron. Okay, now what happens to the neurotransmitters in the synaptic cleft, as well as those that are already bind with the ligand-gated ion channel? Okay, now cholinesterase is an enzyme. Okay, cholinesterase is an enzyme. It appears that these enzymes are present in this synaptic cleft. Okay, so this cholinesterase will hydrolyze the acetylcholine into acetyl and choline. Okay, now we have many acetyl and choline in the synaptic cleft. So reuptake of this acetyl and choline is done by just simply diffuse, okay, back into the synaptic knob of the presynaptic neuron via neurotransmitter transport channel. Okay, you can see this neurotransmitter transport channel. So the acetyl and choline will be reuptake by diffuse through this neurotransmitter transport channel into the presynaptic neuron. Okay. Now, mitochondria. Remember, I mentioned earlier there are many mitochondria in the synaptic knob. Okay, this mitochondria will provide ATP for the choline to form into synaptic vesicle with the acetyl. Okay, so that's the transmission of impulse across the synapse. Now, let's take a comparison. Okay, transmission of impulse across synapse with the transmission of impulse along the axon. Okay, so the transmission of impulse across the synapse involves movement of organic chemical across the synaptic cleft, right, which is the neurotransmitter or acetylcholine, while the transmission of impulse along the axon involves movement of action potential. Arrival of impulse at the synapse, okay, will causes calcium ions to diffuses into the synaptic knob. Remember, this is to further accumulate the calcium ions that will cause the synaptic vesicle to be exocytosized. Now, whereas arrival of impulse at axon will cause sodium ion channels to open. Synaptic vesicles move towards presynaptic membrane, okay, for transmission across synapse, whereas the transmission along axon, sodium ion and potassium ion move across the axon membrane. Neurotransmitters exocytosize into the synaptic cleft, whereas while in the transmission along axon, exocytosis of organic chemical does not occur. Remember, only sodium and potassium ions that are move in and out. Okay, now in transmission across synapse, neurotransmitters bind to specific receptor sites on the postsynaptic membrane, which is the ligand-gated ion channel. While in transmission along axon, binding of organic chemical does not occur. Okay, in transmission across synapse, sodium ion channels at postsynaptic membrane open, okay, to allow the influx or inflow of sodium ions as a result of chemical stimulation. Okay, chemical stimulation here means when the acetylcholine binds with the ligand-gated ion channel, or here I should have mentioned, okay, instead of sodium ion channels, I should have mentioned here sodium ion ligand-gated ion channel. Okay, whereas in transmission along axon, okay, sodium ion channels along the axon open to allow the influx of sodium ions as a result of electric stimulation. Okay, now in transmission across synapse, after depolarization, the neurotransmitters are removed by hydrolase. Now, one example of hydrolase is cholinesterase. Now, whereas transmission along axon, enzymes are not produced to hydrolyze any neurotransmitter. Okay, so that's it for today's class. All right, so happy studying.